that from that positions the number of units allocated, so that can be shifted. So out of those negative value positions, so here I have the negative value position, here I have the negative value position in the loop. From that position, consider the allocated number of units. So here I have 8 and here I have 2. So out of 2 and 8 minimum positions, yes, we have formed a loop over here. So starting from this particular position, wherever we have got the negative Dij value or the opportunity cost, from that position we have to start the loop. So I have started from this particular position. So I have moved in this way. So I could have moved in this direction, but when I take the deviation or when I take a turn over here, so I cannot take a turn because there are no allocated cells. There are no allocated cells. Remember, we can take a turn only in the allocated cells. Only in the allocated cells. So here we have the allocated cells. So I will take a turn over here. So here also I have the allocated cells. That is why I have moved in this direction. And again here I have the allocated cell. I will close the loop over here. So I have closed the loop over here. And where I have started, so I have taken it as positive sign. So in order to balance positive, in the other end I have to mark negative. So here again I have to mark positive because here I have negative value. So again here I have positive value. So that is why in the end of this loop here I have marked negative. So now wherever we have the negative values, so those allocations we have to consider. So out of those allocations here 2 and 8. See here minimum value out of 2 and 8. So whichever is minimum, so that we have to select. So here I am selecting 8 and 2. Out of that 2 is the minimum value. So that is why we select 2 and we reshuffle the allocations. How to reshuffle the allocations? See here wherever we have got negative value, so we have picked this minimum value 2 and 8. Out of 2 and 8, 2 is the minimum value. So add or subtract that minimum value to these corners or wherever we have got the signs. That is nothing but the allocation. See here we have the allocation of 10. So we have a positive sign. So the minimum value we have selected is 2. Add 2. So it becomes 12. So here the original allocation was 2 and the minimum value whichever we have got was 2. So minus sign. We have a minus sign. So there is no allocation. So 2 minus 2 it becomes 0. So there are no allocations at this particular position. Similar way, here I have the allocation of 8 units. 8 units. So 8 minus. I have the minus sign, minus theta. So that is why 8 minus the minimum value 2. I will get 6. And here the new position is this one. So wherever I have the plus theta sign, so that is why we have to add the minimum value 2. So I will allocate to that particular position. So now I will write the allocation. So here the allocation is as it is 5. So here there are no allocations 10. So this position I have the allocation of 2 and here I don't have allocations. Here I have the allocation of 7 for T position. So I have the allocation of 7. And in the corners of the loops, so we have considered 8 and 2. Out of that minimum value I am considering, that is 2. Minimum value is 2. So that has to be subtracted and that has to be added in these corners wherever we have the negative and positive sign. So here we have the negative sign. So that becomes 0. So that position becomes 0. So that will be shifted to this particular position wherever I have the positive value. So here 30 in this particular position I will be shifting that allocation to, and in this corner allocation is 8, minimum value is 2. So 8 minus 2 that is 6. In this position the allocation is 6. And again here the allocation is 10. Our minimum value is 2. So that has to be added to this particular position. As I told you, according to the sign we have here plus or minus the minimum value. That minimum value has to be added or subtracted. Remember, so here minimum value is 2. So that has to be reduced here. 2 minus 2 is 0. So we don't have the allocation. And here I have 10. So positive sign. 10 plus 2 is 12. 10 plus 2 is 12. 10 plus 2 is 12. And here it is 8. So I have the negative minus theta. So that is why minus minimum value. So that is 8 minus 2. It is 6. And here this is our new position or the shifted position. So I have marked it as plus theta. Plus theta. So here I can allocate to 2. So plus that particular minimum value. So that is why this is the new position of allocation. Now we have got 6 allocations. We have got 6 allocations. Now to repeat the same procedure. Repeat the same procedure. You find out UI value. You have to find out VJ value. You have to find out DIJ value, opportunity cost. And again, if you are looking into DIJ values, if you are getting all the DIJ values as 0 and positive, then the transportation cost, whatever we have found out, so that is minimum. Or we have modified the allocations, and that is the minimum transportation cost. So if you get a negative value, negative DIJ value, again you have to go for one more iteration. So similar way, until you get positive and 0 DIJ values as positive and 0, you have to carry out the iteration. So I will write the iteration once again. I have written all the new allocations in this particular table, and now again we have to carry out the iteration so that we have to find out the opportunity cost. Initially we have to find out the dummy variables UI and VJ. So again I am telling you the same thing. See, wherever we have the highest number of allocations, we can refer, or we can take that value as 0. So, but here we have 2 allocations in this particular row, 2 allocations in this particular row, and 2 allocations in this column. So that is why all are equal. That is why I have taken the previous value 0, same value in this iteration also. So I have taken VJ value as 0. So now when VJ value is 0 here, so I have to find out UI value. UI value can be found out using UI equal to Cij minus VG. So here Cij value is 10. Cij value is 10 and VJ value is 0. That is why I have got 10. UI as 10. Now again, wherever we have the allocation, we can find out the dummy variable value. So here I have the allocation. So that is why Cij value is UI value. We can find out as 20 minus, so that is 20 Cij minus VG. It is 0. That is equal to 20. So here I have got the UI value as 20. Now coming to this particular position. So here I have the allocation. So allocation, and I have the value of UI. So that is how you can find out VJ value. VJ value, that is 90 minus 10. 19 minus 10, so 9. So that is the VJ value. I am not going to write that. But again, here the allocation is in this particular position. So here I have the allocation. Here I have the value also, UI value. So that is how 8. Cij value is 8. 8 minus 20. That is minus 12. Minus 12. So that is my VJ value. Similar way, this UI value you can find out. So here is the allocation. So this row, here we have the allocation, and here we have the value minus 12. So Cij 30 minus of minus 12. 30 minus of minus 12. So that is 42. 42 is my UI value. And last one, we are left with this particular allocation. So here Cij value is 40. 40 minus 42. 40 minus 42. We will get that as minus 2. We will get the value as minus 2. So finally, we have arrived at this particular situation where we have got the UI and Cj values.
Yes.
Next, we shall find out the opportunity cost. So we have found out the dummy variables 9 minus 12 minus 12. 10, 42 and 20. Now the next task is to find out the opportunity cost in the open cell. So now opportunity cost of this one. So this position it is D21 position. Opportunity cost is Cij value it is 30 minus Ui plus Vj. Ui is 10 minus of minus 10 plus minus 12. So that is 30 minus of minus 2, 32. I will write the opportunity cost over here. So here it is 32 is the opportunity cost. Next, this position. D22 position. So here it is 50 minus ui plus this one, that is 10 minus 2, so it is 50 minus 8 is equal to 42. So Dij value here is 42. Now here this one D21 position. This is D12 and D13 position. Now it is D21 position. So here it is 70 minus Ui value is 42 plus Vj value is 9. 70 minus 51 is equal to 90. So it is equal to 90. So I have got the value. The opportunity cost is 90. So now this cell, that is D24 position. So Cij value is 60 minus Ui value is 42 plus Vj value is 0, that is by 60 minus 42 is 80. So here it is 80. Now here D31 position, that is 40 minus 20 plus 9. 40 minus 29, that is 11. So here I have got 11 and here 70. D33 position, that is 70 minus 20 minus 2, 70 minus 80. 70 minus 80, that is 52. So D3 position is 52. Now look into the opportunity cost. We have got the opportunity cost as equal to 32. 32 is opportunity cost, 42, 18, 19, 11 and 52. So that gives us the conclusion that all the values are positive. All the values are positive, so that the allocation is perfect. Or when we have modified the allocation, so it has been shifted to this particular position. So now the modification is perfect. So if you get negative value again if you get a Dij negative value, then you have to carry out the iteration for several steps until you get Dij as 0 or positive values. Now, similar way, however, we used to calculate the transportation cost using the allocations. So now calculate the minimum transportation cost. Finally, we have to find out the minimum transportation cost looking into the allocation. So as we used to do for Vogel's approximation or Dish cost entry method, all those methods we used to find out the minimum transportation cost by multiplying this with the number of units. Cost with number of units, 19 into 5, 19 into 5, 10 into 2, 30 into 2 plus 40 into 7 plus 8 into 6 plus 20 into 12. So finally we have arrived at this particular solution, that is rupees 743 is the minimum transportation cost. Thank you.